A black hole is a region in spacetime with such a large gravitational force that nothing, not even particles and electromagnetic radiation like light, can escape once it enters it. General relativity predicts that a sufficiently compact mass can deform space and time to form a black hole. The boundaries of such a region from which nothing can escape is called the horizon of events. Even if the horizon of events has an enormous effect on the fate and circumstances of an object passing through it, no apparent feature can be observed. In many ways, a black hole behaves like an ideal black body, because it does not reflect light at all. Moreover, the theory of the curved spacetime quantum field predicts a horizon of events inversely proportional to its mass. The temperature is in the order of billions of degrees Celsius in the case of black holes and the stellar mass, making them essentially impossible to observe. Objects whose gravitational field is strong enough that light cannot escape were first considered in the 18th century by Jean Michel and Pierre-Simon Laplace. The first modern solution to general relativity that would characterize a black hole was found by Carl Schwarzschild in 1916. Although his interpretation as a region of space from which nothing can escape was first published by David Finkelstein in 1958. Has long been considered a mathematical curiosity. It was during the 1960s that theoretical work showed that these were a prediction of the theory of general relativity. The discovery of neutron stars in the late 1960s sparked interest in the reality of gravitational collapsed compact objects. Black holes with a stellar mass are expected to form when a very massive star collapses at the end of its life cycle. Once a black hole has formed, it can continue to grow through the continuous absorption of mass from the surroundings. By absorbing other stars and colliding with other black holes, supermassive black holes with a mass of millions of suns can form. There is a general presumption that almost every galaxy has a supermassive hole at its center. They are the largest black holes in the known universe, billions of times more massive than our Sun. But little is known about how these monsters form and why they grow so large. New telescopes and techniques give us a new way to look at these giants. While standard black holes are about 4 times the mass of our Sun, their enormous relatives are millions and sometimes billions of times larger. Scientists believe that almost every large galaxy has a supermassive black hole at its center. But no one knows how they got there. The UCG 11700 galaxy may prove useful in solving this mystery. It is known, in principle, how black holes form and grow. A dying star runs out of fuel, explodes into a supernova, collapses into itself, and becomes so dense that not even light can escape its enormous gravity. The idea of black holes has existed for a century, and is described in Albert Einstein's theory of general relativity. In popular culture, black holes are perfectly dark and hungry. They pierce the universe by sucking in everything in their path, becoming larger and more voracious as they grow. Mystery solved. One might think supermassive black holes are simply the hungriest and oldest. Although we perceive the absorption of matter as fast, in reality, the process is quite slow. If you entered a black hole, it would absorb you so slowly that your body would gradually tear, distort, and elongate like chewing gum, and then decompose subatomically. The first to predict the existence of these black holes was Albert Einstein in 1916 in the theory of relativity. The term black hole was coined in 1967 by American astronomer John Wheeler, and the phenomenon itself was discovered in 1971. Black holes are not all the same. They can be classified into three categories: supermassive black holes, stellar black holes, and intermediate black holes. The moment a star burns for the last time, it may collapse. In the case of smaller stars, the new nucleus may form a white dwarf. But when a larger star collapses, it continues to collapse into it, and lead to the creation of a stellar black hole. However, in reality, black holes do not live up to their monstrous reputation. They are surprisingly inefficient in aspirating the surrounding material, even in a dense galactic nucleus. In fact, collapsed stars grow so slowly that they could not become supermassive just by absorbing new material. The holes formed by the collapse of a star are relatively small, but very dense. These celestial objects are 3 times the mass of the Sun, and are the size of a city. These characteristics lead to the formation of a very large gravitational force that attracts all the celestial objects around it. They increase in size by consuming dust and gas from the galaxy. Some researchers believe that supermassive black holes are the result of hundreds, or even thousands of very small black holes merging. There is also the theory that large gas clouds could be responsible. Collapsing together can lead to rapid mass creation. A third theory proposes the idea of the collapse of a star cluster, a cluster of stars collapsing at the same time. Until recently, scientists believed that black holes were of only 2 types, small and large. Recently, research has highlighted the possibility of a new type, of medium size, called intermediate black holes. These celestial bodies would form when the stars in a star cluster collide in a chain relationship. Some of them could collapse at the same time in the center of the galaxy, and lead to the creation of a supermassive black hole. Black holes are incredibly massive celestial formations, but they cover only a small region. Due to the relationship between mass and gravity, they have an extremely strong gravitational force. Under the classical theories of physics, even light can be caught by this gravitational force. Sometimes it happens that the matter attracted by the black hole bounces off, and is thrown out. This is how light jets of matter are created, and even if the black holes are invisible, they can be viewed from a great distance. Recently, the British physicist Stephen Hawking shocked the scientific world with a very controversial idea that black holes, as they were imagined until now, do not exist. He proposes a solution to the paradox of black holes. The physicist argues that black holes are not immortal formations. They undergo an evaporation process that results in the loss of particles. A black hole only 1,000 light-years from Earth has been discovered by astronomers at the European Southern Observatory, ESO. Astronomers claim that this black hole is the closest they know to Earth, and that the system in which it is located can be seen in the night sky in the southern hemisphere with the naked eye. The black hole was quite difficult to notice because it is relatively dark. Black holes tend to light up as they feed on the surrounding stars, revealing their location. But this black hole is a special one that doesn't seem to behave like that. Suppose the first stars formed black holes about 200 million years after the Big Bang. After exploding, they then have about 13.5 billion years to grow billions of times the mass of the Sun. It is too short a time for this.